Hey, welcome to the SkyTour LiveStream, guys. This is Mark D'Antonio here, and I have Daryl Mason with me. Hey, Daryl.
Hello, Mark. How you doing? Hello, everybody.
Excellent. I'm doing all right. We do have clouds. I mean, I can see Jupiter on the screen, and occasionally Saturn pops into view. So I figured we're just gonna go for it and see what happens, right? It's actually, we should have a little while, but we'll make the best of it. Let me just take care of some business here, getting so Daryl can see what's going on and hear what's going on and complain at me when he needs to and scream and yell and carry on like I always do. There we go. All right, so now Daryl sees what I see and we're the same. You got it, Daryl? You should see all that.
Yeah, okay. I see your Skype page now.
All right.
You do sound kind of muffled still.
I don't know why. Oh wait, maybe I wonder if this is gonna help. Does this help at all? Or maybe I don't know. Does this help you at all?
About the same.
Okay.
I can understand what you're saying.
Okay. Well, it's probably important if people also can hear what I say. Dalai says he can barely hear me. I wonder why that is. I'm going out almost in the red on the mic here. So, maybe Dalai has to turn up his volume? Possibly? Everybody else, let me know if you can hear me. That's probably the best way to go. Okay. Okay, Tara says she hears me okay. So, Dalai, maybe you gotta turn up your volume, I guess, maybe. Well, in the middle of the screen here, that little round thing is actually Jupiter. And right here, very hard to see, right there is Saturn. But if I take a photo of it, let me try this actually. Yeah, now you can see it. There's Jupiter right there. And there's Saturn. Here we go. We made the summer solstice tremendous conjunction. We actually managed to see it. I think that's great.
Winter solstice even.
That's right. Did I say?
You said summer solstice.
I did?
Uh-huh.
Okay. Yeah. Winter solstice, as a matter of fact, yes. So there you go. And like I said, we're looking through clouds. I have no idea how long this is going to go, this stream, but it comes and goes, as you can see. But we'll do our best. We will do our best. As it gets darker, they'll be more obvious, because right now it's not even quite dusk. We have a little ways to go.
Yeah, it's just 4:30 there.
Yeah, but I figured I'd start at 4:30 because I could find it in the telescope at 4:30, and there they are, right there. Actually, these look like they're on our moon images. These look like maybe the distance from Plato to from Plato to Copernicus. It's less than that. Actually, it looks like it's even less than that distance if we look at relative distances. Remember, our moon fills, pretty much almost this whole image. That's pretty cool.
Your image looks a little out of focus to me, too.
Well, we are looking through clouds.
Oh, duh.
Yeah, we got lots of clouds right here. And every now and then you can actually see the clouds moving across. I'm watching them here going across the screen as well. I just want to take the time to just say hello to everybody who came on out here. Farva, thank you so much for the donation. That was fantastic. Franco Bruno, how are you? Franco Bruno Brule, nice to see you here. Thanks for coming. And Brandy is here with us as well. And One Man, all right, an NLP channel, Monique Coleman, PG, Daryl, of course, and Tara is with us, and Dagger is here as always. Terry Groff is here, fantastic. Hello, Brittany Abbey. That's a new face. I don't think we've seen you before. Thank you for coming. I'm glad you found it. I mean, we're doing the best we can with clouds, but this is Jupiter here, and this is Saturn right there, at the end of my point of the arrow. And thanks, Dalai, for that. That's I will let him know you said that. He just wished my son happy birthday. That's very kind. Thank you. And of course, Daisy and Zoe Amethyst are here with us as well. You guys are so loyal. I'm telling you. Every time I come on, I see many of you, the same people come out. It's just really good. Just really good. See, Daryl, they like you, man. And if you weren't on mute, I could hear you. You're off mute now, yeah.
Yes.
Okay.
Well, thanks for whoever likes me. I wonder why sometimes.
Oh, you're just fine. You're really good. Isabella, how are you? Andy Morrow, what's going on? Foggy there? Well, foggy here. Look, clouds. So we have some time to let it get dark. I know that we actually have a evening here where we're gonna have mostly cloudy skies. So this is a little treat. I don't know how long this stream's gonna go. I'm hoping for just some moments of clarity where we'll be able to actually look at Jupiter, which is right here, and Saturn, which is right there. Look how close they are. I mean, literally, Saturn's at the end of my pointer. So that's pretty close in the sky. Now, from looking with your eyes on the ground, this is not too close that you couldn't see them as two separate objects. If they were about a fourth of that distance, fifth of that distance, it might get a little tough. But there's some eagle-eyed people out there that can really count, say, like many of the stars in the Pleiades. And this is an example of where we have a planet that's coming and going. And a fainter one, as Daryl said yesterday, we talked about this yesterday. And by the way, thank you for those of you hey, Julian, thank you so much. Julian Vibrajo, thank you very much for that. That was very good of you. I appreciate that. Merry Christmas to you, too. It's a beautiful winter solstice, and I know that we'll do our best to keep this going. I wish I had control of the clouds, to be honest with you. See? Look at Julian says your Daryl's great. See that?
Aww.
See that? That's
Thank
right.
you.
So if you ever doubted it.
What did I say yesterday?
Well, you said everything is better with Amanda, but that's...
Well, you sounded like you were starting a story or something. You said something I said yesterday. Then you got
yeah. We talked
diverted.
Yeah, I know. The distances to Jupiter is about 500 million miles away, and Saturn is a billion miles beyond that. So, almost.
No, it's Jupiter is about 500 million from us, and Saturn is about 1 billion from us.
Right.
So.
That's
about
right.
Another 500 million from Jupiter to Saturn, I guess.
Yeah, twice as far from us as Jupiter.
Mm-hmm.
Yeah.
And what we're saying, Amanda was asking last night, it's an example of what's called syzygy, S-Y-Z-Y-G-Y, syzygy. That's when three bodies in space form a straight or nearly straight line.
Mm-hmm. So
I love that word. If I ever get a personalized license plate, I'm going to try to get a syzygy license plate.
Well, in here, in Connecticut, I think I would only be able to get a syzig. They don't let me get that last Y,
Really?
Yeah, I don't have that many letters. I think I've got maybe I could.
6 letters?
Yeah, I think I get 5 letters actually.
They used to be here, all you could get I think was 6, and they may have increased that to 7 now.
Oh. Yeah.
Sometimes you had to get creative with your spelling, do it like phonetics or something.
Yeah, I've seen a whole bunch of cars like that. My favorite license plate I've seen, but it was a New York license plate, and it was available if I wanted it here, but I didn't do it, is Spectra. I thought that was a really cool license plate.
Uh-huh.
Yeah. However, I will tell you this. Those of you who know who Marianne Robb is, Marianne is a police officer in Arizona. She is also one of our most ardent supporters, and she got the license plate STLS, SkyTour LiveStream. Yeah. And actually, and that's fair, because the observatory is named after her and the people whose land it's on. So it's actually called the Hain-Modlin Observatory. And so with all her help, I think it was the least we could do was to name it after her. And then when she got the license plate, I said, more power to you. I'm so proud. Hey, I'll get STLS 2 or STLS 1 or something like that, So I don't mind. If people want to know what it was, if they want to know what it is, they'll ask. Oh, look, there's Saturn. I see it now. Look at that, the guy. See? There we go. And again, it's not even, it's about dusk right now. It's 4:40 actually. So,
would you believe it is about 60 degrees here today?
It was actually 50 degrees here. So all the snow inside the observatory that came in through the tiny little cracks melted. So I have puddles on the floor, which is why you separate all the equipment from the floors, which is what I did. It's all Dale, look at Scissor G. That's a good one. Look at it.
There you go, doll.
That's cool. That's a good way to spell it, especially for the license plate. If we want to do it here, I like it. I like it a lot. Very good. So that's a true statement for what I think we're going to encounter tonight. Something I said earlier, and that is that I believe that the clouds will be sticking around for a while, but I wanted you to see it. I wanted you to be able to see it with your own eyes through the telescope. Some of you are several thousand miles away, but here you can see it. Some of you have very clear skies, so the answer to that is why are you in the stream? Go outside and look at it, Yeah. Hey there, Captain America, what's going on? And
I'm going to be out looking in a couple hours myself, but it's still, full daylight here.
Yeah.
I'm 2 hours west of Mark.
By the way, I got to say hi to Volkisch Fraulein. Hi there, how are you?
Hello, Fraulein.
Are you in Germany? Hello there, how you doing? Donald Kunzer, hi there. Yeah, there's Saturn, right? You're right, Donald. He was just pointing out that Saturn is right above Jupiter. You can actually see the rings now, so maybe we're getting some clarity. Let me take a picture and see if an image can give us any indication. If I don't miss my guess, I think oh yeah, look at that. You can see the rings right nicely there, Daryl. Look at this. Okay. Now, this is what's cool. Okay. There it is, folks. Look at that.
All right. I think that's a better view than the last time we looked. Saturn's a little more distinct.
It's higher in the sky. That's why I wanted to start at 4:30.
Oh, okay.
Yeah.
We'll probably see some moons of Jupiter popping out here in a bit. Might even see Titan.
Yeah, I was thinking about
Saturn's big moon.
Yeah, I'm wondering. Let's actually go check that out. We'll come back to this. This is a photo that we've taken, but I can always make that available to everybody as usual. But if we come back to our main screen here and we come back and look, where are we now in regards to? I'm going to add my atmosphere back. Okay, and there it is right there.
Europa should be to the right, and to the left from closest to Jupiter. The farthest out will be Ganymede, Io, and Callisto.
Okay. And
see how many we can see.
Okay, and Titan is to the right. See that? By just a little more than the length of the planet with its rings. It's right there.
I see that, yeah.
So let's go back here and go back to our photo to see if we had already captured it. I doubt we did. We gotta typically expose it quite a bit, but Titan is the second largest moon in the solar system, so we should be able to see it. Maybe not on this exposure, but on the others.
I forget which one's biggest.
Ganymede.
Ganymede?
Yes.
Okay.
Ganymede's the biggest, and then Titan is the second largest. It's only, I think that's the way it goes. It's edged out by just a tiny little bit.
Yeah, and they're both bigger than the planet Mercury, right?
Yeah, they are, which is kind of cool. Yeah, Mercury's a planet. It's sitting there all self-confident with itself. You know, that's right, I'm a planet. That's right, I'm bad. I'm a planet. Meanwhile, Pluto's out there going, I can't believe this. And Titan's like, yeah, what about me? I'm stuck behind this big galoot here. You know? Ganymede's like, yeah, you think you got problems.
There's a funny cartoon out of Pluto and Neil deGrasse Tyson. You may have seen it before. I'd send it to you. You could post it if you want, but it's not very nice. It involves the Hawaiian peace sign, and it's really funny.
Okay.
Neil deGrasse Tyson says Pluto is not a planet, and Pluto violently disagrees, shall we say.
Oh, wow. Another exposure here. This is actually turning out to not be a bad night relative to the problems that we've had with the night. You know, this is actually not so bad considering there's clouds out there. And we're looking at it through dusk, which is it's why you see the little purpley glow, but the filter is giving us that purple glow as well, which I can actually correct. If I go correct that, that's more like it. I just did this. I have a little correction that I do, and that might be a little better. And I'm a little too high of an exposure to see the details on Jupiter's cloud tops, but we can see the rings of Saturn. Look at that. Oh, and there's Titan. There's Titan right there. Can you see it?
Not yet.
Okay, I just saw it. Okay.
I'm sure it'll pop out here in a bit.
Yeah, no, this was a photo that I took, so I don't know why I just saw it. All right, let me,
I don't know if, with all the atmosphere and such, and still it's light out there, JavaScript Jupiter says that the Great Red Spot is also visible over toward the right side of Jupiter.
I do. I see that as well. All right. And by the way, whenever you're doing anything with astronomy, guys, all of you listening, you know what you do? Move the image around if you can a little bit, and that might help you see some of the other details that might be hiding in the image, like maybe a semblance of a moon that just is quite at the edge of visibility. By moving it, it'll separate it from the background noise that you might be seeing because of your eyes. Okay. Oh, thank you, Volkish, for telling me you're on the West Coast. Thank you. But if you notice, the rings from end to end are still a little bit less than Jupiter, which I think is pretty interesting. And again, Saturn is twice as far away from us as Jupiter is. You know, so, and Saturn's size, that round ball inside there, that round ball of Saturn's main planet without the rings is slightly smaller than Jupiter. So you can see that, you know, if you think three-dimensionally, you can see how you got to go far, 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 far away, and there it is, way in the distance. You know, so that's kind of cool. Mm-hmm. So let's go back. Oh, I'm thinking we're getting some clarity here. Let me try to drag out some Jupiterian detail, Jovian detail, in other words. half a second at 50 ISO. Oh yeah, where it's through light clouds, but we can see some detail. And you can see this reddish area over here to the right. That's actually Jupiter's red spot. Looks like it's just right of center, not all the way over. What is it? What's the Jupiter site say, that it's to the right? Because I see it just right of center on the main band.
Let me look. It shows it close to the right-hand limb of Jupiter right now.
Okay.
I've noticed that the timing on JavaScript Jupiter can be off a little sometimes.
Okay.
Especially with the location of the Great Red Spot.
Okay. This is a case, by the way, guys, where moving it around can actually help you to see details. So if you move Jupiter around and you're forced to follow it with your eyes can pick up other subtle details that might be missed. It's sort of what I call reverse averted vision. And what's that? Well, if you're looking at a faint object in the telescope and you're looking straight at the object, you might not see it. But if you look to the right, then you will see it. Now, that's because the black and white receptors in your eyeball, okay, they're ringing around the outside. So peripheral vision is brighter because they're very sensitive relative to the cones, which are the color receptors. But if you stimulate multiple receptors by moving this image around, then sometimes the rods, which are the black and white receptors, and the cones, which are the color receptors, will actually show you more detail momentarily. Now, I did this with a large 20-inch refractor, which is, I guess about 35 or more feet long. It's so big the whole floor moves up and down to meet the telescope. So it looked kind of odd when I would be, like when I was looking through the view, when I would actually just move the telescope back and forth. People are going, "What are you doing?" You know, this telescope is a Alvin Clark refractor. It's one of the highest rated refractors on the planet. And I'm like, yeah.
Hey.
Huh?
Oh, I'm sorry. Go ahead.
No, that's okay.
Carol's here.
Carol, hey. How are you, Carol? Carol, would you like to come on with us? I offer that because Carol is a KGRA radio host with us. And you guys are all worth it out there. But Carol has observations in a way. And besides, she's also doing the audio book of The Populated Universe, which is the book that I wrote. So I'm forever indebted to her, and I'm always trying to give her some type of payback for all the things she's done. So if you'd like to come on, Carol, just let us know in the chat, and we'll bring you on. All right. So we have this beautiful view now. It's actually reasonably good. I actually think I like it a lot. I mean, I would like to go up to see the moon. So let's see how much. Yeah, see, it's still pretty bright out there. See, Carol Hub wants you to join. Okay, give her 3 minutes. Okay, I know what that means.
She says, "Give me 3 minutes."
Yep. Yeah, I know what she needs. It's
Wasn't that an old Leonard Skinner song? "Give me 3 minutes."
Really? Wow.
That's a joke. It was "Give me 3 steps" is what it was.
Oh.
Give me 3 steps. Give me 3 steps. Give me 3 steps toward the door.
That's right. Wow, look at Saturn. It looks pretty good. You know what? This is one of those things, guys, that is really interesting. And Farva's right. Jupiter is, parallaxing. I know what you mean, but we're seeing parallax with Jupiter and Saturn, and that's not what we're seeing visually right here. But if Jupiter is moving as the Earth's moving, then we can detect the movement of Jupiter against Saturn, and we'll see that movement of Jupiter against Saturn. It doesn't mean Saturn or Jupiter is moving much, much faster than Saturn. It is moving faster because it's closer to the sun, but it does mean that the relative motion, the appearance of relative motion will be higher watching Jupiter move. So that's the parallax effect that we talk about. In fact, Daryl knows this too. I mean, I know quite a lot about parallax because when I was getting my astronomy degree, I spent much of my time working in a parallax program. That is to say, a research program. And I would take photos of stars, and we'd send them the images down to Yale University to actually have the star images measured very, very precisely. And from those really, really precise multi-significant figure measurements, we would end up being able to determine 6 months later what the parallax was for that particular star. And then we would do it all over again.
That's not just astronomy, that's astrometry.
That's astrometry. You're right.
Excuse me, astrometry.
No, that's okay. I mean, I've heard it said many different ways. Even I've had people tell me it's astrometry, it's astrometry. It's like, okay, fine. It's astrometrics is what it is.
Hey, Amanda's here too.
Cool.
Hi, Amanda.
Hey there, Amanda. So I'm glad Amanda could join us because now she can see this. Ta-da! Look at Jupiter and Saturn in the same view. This is astonishing, guys. Really astonishing. And some of you I might have told before. This is a case where we've actually had back in the age of Galileo. He was alive when this last happened, and I think that's pretty interesting, you know. And by the way, just in case you don't know, if you guys have not subscribed to SkyTour LiveStream, what are you waiting for, man? It's free, really cool, fun astronomy. You know, we're not boring here. You know, as Daryl will tell you. No, don't ask Daryl. He might say I'm boring. Shh, don't ask him. Don't tell him I said that.
I heard you.
Oh, darn, I gotta get this technology out of my head. Yeah, so when we look at this beautiful scene, we have to remember that we're looking at Jupiter 500 million miles away, and Saturn, and that's from us, and then Saturn's 1 billion miles away. So it's another 500 million miles past Jupiter. Yet right here in the sky, they're about 1/10 of a degree apart. You know? Let's just go back to our main view here and see if...
Can Amanda come on too?
Oh, of course she can. And is Carol ready?
She says hello again. Carol does.
Okay, so let's go add Carol and let's add Amanda. I would very much like to have both of them on board with us because we're doing this really cool thing.
Like a little party.
Well, yeah, you know. I mean, I can stay quiet. No, I don't have to talk.
We'll have our own little solstice conjunction party.
That is correct. All right, so let's bring in Amanda and Carol. All right, so we are getting in touch with them. They should join us shortly, I would hope.
You talk about parallax. You know, I mentioned during the SkyTour radio last night. I watching Jupiter approach Saturn for the last 10 years.
Yeah, you said
hello,
that.
Hello.
Hi, Carol. Welcome. Thank you for coming.
I am so glad to be here. This is great, and Amanda is in the house.
Hi, Amanda.
Now, what I need to do is figure out this is the same thing that happened. It's
you're
a
hearing the
delay.
echo. Yeah, you know what you got to do? You're watching the YouTube video, so you got to go to YouTube and turn it off. Not turn it off, but mute it, because you're hearing the voice coming later, because there's a delay. All right? And my screen is shared, so you should be able to see the screen live.
Yes, and I think now I'm not audio impaired.
Very good.
Excellent. What do you know? Okay, yep, I am seeing it.
Oh, and look, we've got some Galilean moons over here. We have Europa on the right, I think. Is that what you said, Daryl? You checked it out.
Let me check again.
I'm going to go
beautiful.
down. It is beautiful.
Europa is on the right, and on the left of Jupiter should be Ganymede, closest, then Io, then Callisto.
Okay.
Not that we'll necessarily see it. I see 3 moons coming and going, but I see 3 on the left right now.
Well, look, we're looking through some relatively high clouds, and look at what we got. Okay, we can see the bands on Jupiter, and just above we have Saturn. Okay, now I'm going to go take a photo. That was to show the bands on Jupiter. Because we were using cameras, the sensitivity has to be, adjusted. So what I'll do now is Yeah, you see the moons there, Captain America. Let me make sure you can see the moons. Amanda, you with us? I thought she was.
Hello, hello. I don't hear her.
Okay, I did add her. Maybe she.
Did I just hear her say hello, hello?
No, I didn't hear it.
I think that was me, Daryl. So that's doing my Amanda impression.
Okay.
Okay. Well, that's okay. Amanda, let us know. I know I just added you without saying anything. Maybe you can't come on. I don't know. Hey there, Rems. How you doing? Great to see you. Again, for those that have just joined us, keep in mind that we are a live observatory, and we stream all the time. We have 2 observatories now. This one is in Connecticut that we're streaming from, and the equipment that we're using tonight is being shipped to Arizona, to our Arizona Desert Observatory, Saturday, this coming Saturday. And we got a private person who's going to drive it out there, who owns a shipping company, and his name is Keith Ickes from P&K Space Imaging. And
terrific. If
you need anything carted and carried, Keith is the guy to get, because he is literally so very responsive. He's called me several times to make sure that I've got everything lined up and ready to go, and he's actually helping babysit me and making sure I get all this stuff out there on time. And I think that's really wonderful. So if you get a chance and you have anything you need moved, talk to P&K Space Imaging and Keith. And the reason that Keith is so good about this, and the reason that Keith and I are very good friends, is because of the fact that this observatory in the desert is also going to host a P&K scope. So Paul is going to have a scope. He's going to bring it out. He's the other half of P&K, and he's going to install it out there. But we can't go live with the other scopes. There's going to be a total of 3. The third one is going to be a wide field, beautiful Milky Way telescope. And the sky out there literally makes you cry. It is so unbelievably beautiful. Okay? Look at these clouds. You see these dark clouds? They're just kind of skimming by. You'll watch the moons of Jupiter fade a little bit and pop. So anyway, the sky will make you cry out there. It's beautiful. And we're going to have 3 scopes. But you got to understand, internet access is kind of a big thing out there, So we need to have internet access. So how would we get internet access? Well, we're actually going to do what, and Daryl called me a traitor yesterday. We're actually going to use the Starlink constellation to get our internet. And I entered SkyTour LiveStream into the beta program. And as soon as it's ready, we are going to be able to do this. But until then, we have to use the satellite internet, which is considerably slower. Unfortunately. Hi there, Ole Billy. How are you? I'm sorry we're not on Zoom. This is YouTube. So that's interesting, though. I wonder if we could simulcast on Zoom.
Aha.
In defense of myself, I believe the word I used was turncoat, not traitor.
Oh yes.
Yes. Turncoat.
It's a T word. Yep. It's a T word.
Yeah.
That's fine, Daryl. Yes, I was a sort of a turncoat in that regard. But I think that's pretty cool. Hey, look at it's high speed, low drag. I haven't seen you for a long time. Thank you for coming by. So good to see you. Look, there's Saturn and Jupiter in the same frame. You can even see the bands on Jupiter. We got this exposure just such that we can see it.
I see 2 moons to the left of Jupiter right now.
Actually, you see Europa as well.
You might. I don't. Not yet.
It's right here.
Don't see it yet. I'll give it a few minutes. Sky gets darker.
See, no, this is a photograph. Okay, this is the last photo, but notice you see the 2 moons. You've got 1 moon here, 1 moon here, and then there's a moon right there. Do you see it now, right above the hand?
Yeah.
I don't.
If I move it a little bit, maybe you will.
Oh, it jumped out at me for just a second.
There you go. See, that's why moving things are such a good idea. Look at Saturn. It's really beautiful. And the thing that's weird about this is we're seeing how looking at the planets through light clouds sometimes helps. It almost acts like a filter, and as long as they're homogeneous, meaning pretty much the same veil of material and density, then the images can be really stunning. You certainly don't want to look through clouds all the time, of course, but this is something that might be of interest. Let me just take us now. I'm actually going to go up above 50 ISO. Incidentally, I have to just say, for those who have joined us just now and have been here for the first time, let me just explain how this works. Over here, right above me, okay, this is the telescope control section. This part right to my left here, this controls the direction and movement of the telescope. This down here is the telescope computer and the focus. And then right here, you see it says narrowband 2 right here. Narrowband 2 is the filter that we happen to be using right now. And you'll see that there's arrows behind my head right there. And these arrows give us the ability to change the filter. So this is narrowband 2. If I go to one now that's a little bit different, it's a darker filter that shows us different things. You see the filter wheel roll right through. And now we have a different view of this entire scene. And what I'm going to do is take a picture of this. But I'm going to increase our settings to 320 and then drop down from 30 seconds because that's really too much for you to have to wait. So let's do 10 seconds. All right, actually let's even reduce it a little more till I can just barely start to see Jupiter's detail. Might not work. Let's just go to all right, we'll do 6 seconds. All right. Hey there, James Dugan. How are things down under in Australia?
Hello, James.
Look at that. See, this is a beautiful shot. We can see all the moons. Look at here, Daryl. We have Europa. I believe that's Ganymede out there, is it? Or Callisto. And this might be Ganymede, and this is probably Io.
Yeah, Callisto's farthest one out. Io's in the middle. Ganymede is closest on the left, and Europa on the right.
All right. This is beautiful, though. This is the actual view that we have now in the telescope. This is not the live view. The live view is right here. Okay, that's the live view. And I'm just going to turn on the infrared light in the observatory so we can see the telescope clearer. There we go. All right, and so this is our beautiful view. Now, going back to what I was saying, so this is our telescope control system right up there. Okay, this is me. Hi. And now over on the other side here, this is our observatory view. This is the view into the dome where we can actually see what's going on in there. And that is the telescope, okay, obviously. And then up here we have the camera control system. So here is the exposure time. That's 6 seconds right now. And then the sensitivity is right here. This is called the ISO. All right. And this, so that's camera control, telescope control, me control, and of course, observatory view. So, and then in the middle of it all is the live view. Now we can make the live view exclusive. We can do whatever we have to just, show you the live view and so forth. But it's good to be able to, for people to see what's going on. We actually, I've got like, every time I stream, I have about 4 to 5 things happening all at once. Now, over the years, I've become very good at doing that. Because in the past, I've been a performer. I've done all kinds of things on stage, and it's been the case where you've had to do 5 or 6 things on stage all at once. And so doing this is like a cakewalk. This is great stuff. And then, so I'm using that ability to try and make this as exciting for all of you as possible. Me moving around is kind of cool, right? I mean, there's Jupiter right there, and I think Jupiter is neat. It's like a weatherman. Jupiter will be cold and dismal for this evening, followed by Saturn, which is going to be even colder and farther away from the sun. But it's neat stuff, and I'm glad that we can actually watch it and check it out. Now let's see if on this particular filter, let's go to 20 seconds. Notice on the upper right, 20 seconds. And I'm going to increase our sensitivity a little bit. 4,000. And now, let's actually see if we can get Titan to show up. Titan is going to be right to the upper right of Saturn here. Okay. Holy Billy says, okay, 1 second there. Holy Billy says, millions of taxpayer dollars involved with NASA, and they are nowhere to be found during this event. Why?
Well, it's not really science.
It's not really considered science, but it really is science, you know?
Well, I mean, it's public, you know, it's consciousness raising.
Yeah.
I think that's good in as excuse as any.
Yeah, I agree. I mean, all you have to do is look at the number of people that are paying attention to our stream right now. Okay,
Sure.
These people paying attention to our stream, and there's 76 of you right now. You guys are, you know, interested. You want to know what's going on. You know, inquiring minds want to know. You know.
Oh, it's pretty.
It is. Hey there, TK and Zadarak. How are you? Cyrus Vix, what's going on? Thank you for coming along. Make sure you guys subscribe and hang with us. We did not expect the clarity that we're getting tonight. We're actually just taking it and running with it because we've actually had an issue. I'm going to go back to the other filter here. So I'm going to go down to this guy right here and go to narrowband 2. So I click the button, and then now we get a better view. It's a little bit wider of a narrow band, so we actually see things better. You can see this haze around Jupiter. That's because we're watching this whole thing through light clouds, which you can actually see the modeling on the screen, and they slowly are moving. So I think that's pretty cool. Yeah, see, it gets bigger and smaller. So if I reduce the exposure and go down to sub-second shot. Okay, let's go down to like this. Let's get a Saturn shot. Now we're going to be through light clouds, but let's just check it out anyway. Wow. Look at that. Daryl, that isn't bad.
That is unreal.
That isn't bad, Daryl. Look at that.
Mm-hmm.
You know? Now there is some noise in the image, but that's because I am, if we go back here, that's because I'm at 4,000 ISO. I'm going to drop that. Okay, down to 1,200 or so, or 1,000, and then I'll just increase this exposure from a quarter second back up to bring it. Now, the interesting thing about photography is the exposure setting and the ISO sensitivity, the sensitivity of the sensor and the exposure setting, they're related one-to-one. If you go up in exposure and down in the ISO setting, you get the same picture. Okay, don't go. Just that's what it effectively equates to. There's more to that, but you really want what you want is the lowest ISO that you can go with the lowest exposure you can use, and so it's constantly playing up and down to get the right settings. So here, if we reduce the ISO, we see that it gets a little dimmer. All right, that's better. All right, the lower ISO means less noise in the image. You've seen if you take a photo with a very fast sensor, you get this grainy look, this stuff, that digital noise. We don't want that. We want that gone, you know? So let's just take this picture 1.6 seconds. Maybe I'll drop it just a hair to 1 second and do that. And now we'll check it out. All right. Oh yeah, look at Saturn. It really looks so pretty. And let me just maximize for you guys. Look at that. That's not bad. And now you can see, well, we can see that all the moons. Callisto is very dim over here, but you can see it. But we can always show it better. So here we have Europa. All these worlds are yours except Europa. Make no landing there. Use the others together. Use them in peace. Remember that movie, guys?
I do.
You do, I know. Does anybody in the chat remember that movie? All these worlds are yours except Europa. That's the way it begins. What movie is that from? That's a question for the chat. Now, let's bring this up a little bit. We'll go down here, 400, and then up a little bit. All right. Okay, a little more.
Old Billy in chat is saying that NASA is nowhere to be found, that there isn't even one single telescope aimed for this event.
Yeah. But,
yeah. Wow.
That's okay. I'll do it for them.
Yeah, exactly. What do we need with NASA?
Yeah.
We got Mark and Daryl. And Amanda, where is she? She is in chat.
Yeah, is she actually going to join us? I didn't see if she said she was ready. Hey.
Amanda, please join us.
Calling
Hey there.
Amanda.
Hey, Wilbur Wobbler. How's it going? Nice to see you here. And Willow Wisteria. Nice to see you as well. Wise Eye is here. And awesome. Cool. Make sure you guys subscribe. All right. SkyTour LiveStream is free. It's a live observatory for everybody. And we really enjoy your company.
The big dog is going to guess at the film title.
Okay.
Is it Childhood's End?
Oh, no. But Donald Kunzer. Okay.
Oh, I missed that.
Donald Kunzer down below.
Oh, yes, there we go.
You have correctly answered the question. It's 2010.
2010.
Yeah.
Yep.
Really
That
good
was-
movie.
First sequel to 2001.
Yeah.
Right.
Starred Roy Scheider, as I recall.
That's right. He was on the ship there. I can't remember the name of the ship they were on, but they went to find the old Discovery, which was pirouetting and spinning in space over years of being pelted with micrometeorites. Uh-oh, we're getting clouds. Look at this.
Oh, no.
Yeah.
Well, Amanda says she's coming in and just give her a few, and she can help us make the clouds go away. Collective consciousness, right?
Yeah. Or maybe they're coming because she's coming. I don't know.
Oh, no.
Yeah. No.
Nah.
I normally...
Be nice.
He's wonderful. I normally have the all sky cam running, but it's packed behind me to go to Arizona because it's going to be the observatory's all sky. Hey there, Dennis West to us. How are you? And look at Pedro C47, and it's a big dog. Nice for you guys to see you come back again. I guess we should have some wonderful people that are joining us tonight. This is
The
great.
daylight crowd.
Yeah.
Mark, Carol, excuse me a moment, please.
Absolutely.
Okay, Daryl,
Be right-
we'll be right
be right
here.
back.
Let's do 6 seconds at 800, Carol, and see what this actually gives us. I mean,
Oh, let's.
yes. Thank you for joining, by the way.
Oh, thank you for inviting me. And thank you to Andy Morrow, who gave me a heads up on Skype about this.
Fantastic.
Or I would have seen it in the archives and gone, well, phooey.
No.
But yeah, this is terrific.
Yeah, there you go. This is what we've got tonight. All right, we have Saturn right here, and we have Jupiter right here. You can even see this beautiful red cloud band on Jupiter. You can see more of the bands, and I exposed it so we can see the cloud bands on Jupiter. So Saturn's a little bit fainter. Saturn is twice as far away from us as Jupiter, but the main planet itself, this round part of the planet, is just a little bit smaller than Jupiter. So it's quite distant. So there's a lot of distance, about 500 million miles between this here and that there. Okay.
That answers my question.
Oh, really?
Yep, there we go. Yeah,
Oh,
thank
okay.
you.
Now, another interesting thing that might be interesting to some of you is that this planet Saturn out here with the rings, okay, which you just don't see right now. So let me try and make it a little more obvious. Saturn has actually has rings that are actually disappearing. Did you guys know that? Saturn's rings are going away.
I did read something about that, and of course, obviously, it's a gradual, long process, right?
Mm-hmm. Yeah, it is a very long process. Exactly right. And what happens is the rings are sort of an aberration on planets. Okay, and meaning that they are typically an intermediate step towards something else. And what's that something else? Well, that something else could be the fact that the rings are going to be raining down as they do into Saturn's upper atmosphere, and the particles. The ring particles are mostly ice. So the sun's energy hitting them does not melt them. And that's always been something people have a trouble understanding. And the reason that it doesn't melt them is because ice is very reflective. And the only thing that we know about in space, the only thing that occurs in space that matters, is absorption and reflection. So if an object can absorb radiation, it can heat up. If it can't absorb radiation, then it's going to reflect that radiation away, and it will not heat up internally. So that's why ice can live for a long, long time in space. Okay? So that's why Saturn's rings, ice particles, subject to ultraviolet energy from the sun, less than Jupiter, less than Mars, because Mars is closer, and certainly less than us. But that ultraviolet energy is still there and can still, melt out the rings. So why hasn't it done so? It hasn't done so because of the fact that the rings are made of this icy, high brightness material. We call it a high albedo. That's ALBEDO, albedo. And so when you look at Saturn right now, okay, you can see, hey Daryl, welcome back.
Thank you.
You can see that Saturn's albedo is quite bright. And so when we look at it, all right, and if I just drop it down to about here, I think we got we're only light clouds now. Okay, so here is just this is so beautiful. My gosh, it's really such a gorgeous view. You can see the Galilean.
That is
moons.
nice.
Isn't that nice? And Saturn right there.
Is.
All in the same view, guys. And we're waiting to see Titan, which is up around here. Right about there.
I see a moon right at 12 o'clock right over Saturn. Very close.
I see that.
I do too. Mm-hmm.
I see that. Let's but if you would see Titan before that, so that could be something else. Let's just, I'm going to bring us up to say 10 seconds. It'll be all overexposed, but I would like to see Titan in this right about here.
You're going to hear Mr. Tea Kettle go off in a minute.
That's okay.
Oh, good. We like Mr. Tea Kettle.
There we go. There's Titan. Look at that.
Oh my gosh.
And we got another one over here. And there isn't one at 12 o'clock, so that's an artificial thing. You'll notice that the color of Titan looks a little bit orangey, and that's because it is. And you can see that orange color from here. Now we're also getting this blue and red. That's a chromatic aberration effect that would have to be corrected out, which is fine. But Titan is definitely an orangey color, and it's very, very clear.
Got one over to the left, too.
Yeah, I'm not sure if that's a distant moon. It looks like it could also be a star, but I think we have to check, because usually Titan is the brightest.
Yeah.
Hey there, Shay Shay. How you doing? Bobby Burgess, welcome. Stan Luna, welcome. Good to see you. If you guys haven't subscribed, run off and do that real quick. And Weird Guy's here too. Subscribe to SkyTour LiveStream, hit the bell, get notified. We're doing the live observatory, and we do this on all clear nights. And currently we have this telescope we're using in Connecticut, in our Northwestern Connecticut Observatory. And we will be using our Arizona Observatory probably in January. And Marianne Robb is here. Hey, look at that. Marianne Robb, I was talking about you. You probably heard me.
Of course she did.
Yeah. Well, Marianne doesn't get her alerts, apparently. And she's like one of the biggest supporters of SkyTour LiveStream West.
Well, phooey.
Yeah. Well, she's just got a lot going on.
Yeah, she says her phone has been acting weird.
Yeah, it has. I was talking to her today, actually. And she was doing some, what do you call it? A restoration on the phone, actually. Yeah. As
opposed to a restoration.
Oh, boom, boom.
Oh, yeah. Yeah, it's a conversation I'm going to have with you privately, Marianne. I had a great, amazing dream last night about a police department and officers. And so, anyway, yeah, I don't know.
Oh, sure. And leave it out. We can't hear it. Great.
No, well, I mean,
It's
there's no
fine.
punchline, et cetera, et cetera.
Okay.
So, but it was wild.
Yeah. So let's so this is the view that shows us the moons. Let's go up a little bit more. Let's go there.
Oops.
There it is. Not
It's
the problem,
Mr. Tea
Daryl.
Kettle.
Be right back.
Ooh, that's loud. I cut the volume a little bit just to make sure that it doesn't make people go, ah. Hi, Wise Eye. Yeah, this is the closest. They're 1/10 of a degree apart in the sky. And if you know how big that is, if you want to know, if you hold out your hand and you hold up all your fingers like this, the pinky finger is about a degree in width at arm's length, okay? So it's 1/10 of that, okay? So that's pretty cool. Pretty cool. Okay, let me do something here.
Okie dokie, thank you.
Sure. Or we'll do 15 seconds at 3200 here just to try and catch a few more moons. Because I did see some down below Saturn. So we probably would be able to see a couple others. The views are really quite astonishing. Oh, I guess the had a little wind there. We got a double Saturn out there now.
Oh.
Yeah. Look at that. Yeah, that's what happens when you... That happens sometimes. Okay, so Genghis, what's going on? Welcome. Nice to see you.
Go Captain America asked a question a few minutes ago. I'm paraphrasing him, but he said he has seen various numbers out there. This happens every 800 years, 400, 200, etc. May I respond to him?
Oh, please do. You don't need my permission for that.
Okay.
You don't need my permission for much.
As I've said before recently, Jupiter and Saturn come together about every 20 years. Now, some apparitions are better than others. This last happened in the year 2000, but it was either a very poor view or it happened when Jupiter and Saturn were behind the sun from our point of view and we couldn't see it. Before that, it happened in 1980, and it wasn't a very good view either. There are various numbers out there. I saw one number that I think was like the year 1202. The number going around most is the year 1623, 397 years ago. Galileo was alive, so that's the number I go with. This is the closest apparition since then. It's sort of a roll of the dice thing. Sometimes we get a good apparition, sometimes we don't. Usually we don't get one not this good, not for 400 years.
Yeah.
And they call it a great conjunction because it only happens once in 20 years.
Oh, I thought it was because it's great.
Well, it is. I mean, seeing's believing.
That's right. All right, I'm going to go into focus mode here and see if I can do a little more focusing. So just a moment. You don't see anything yet, but you'll see it in a second. It's gonna bring it in and it'll be pretty bright. There we go. All right.
This is pretty historic.
Yeah, it is. And it's pretty. And it's historic. It's all those things.
All that.
Yeah. Okay, so I went there. I got to go the other way. Okay. Oh. Darn it, I'm trying to focus and there's clouds coming through. This is no good.
Okay, everybody, take a deep breath and blow those clouds
Away.
Yeah.
Let's just do this. Let's pull in Saturn here. Saturn is behind the clouds. Okay, well, we'll check back in a moment, but I do think that we had some really pretty views here earlier. Okay, so this, when we looked at this image, okay, here we had Saturn.
Whoa.
This is Titan. And we have another moon right here and another moon right here. Maybe two. We'd have to go look and see. And to see, what we do is we go here and we look in. And what do we got? Okay. So that's Re. All right. This moon that's right here is Rhea, R-H-E-A. That's Titan. And this is Stellarium, by the way. They're actually it's free. And then we have Dione and Tethys over here on the right. And Dione and Tethys are those two little ones that I did think I saw right there. There they are. You can see them. Dione and Tethys. All right. Then down here at Jupiter, again, overexposed so you can see the moons. Okay, this is a star. We have Jupiter here. We have Io right here. We have Ganymede right here. Callisto right here, and Europa right here. Now, what's interesting about Europa is, well, it's fascinating, of course, but Europa has some, has some really impressive, has an impressive resume. It's a possibility that Europa is a location where we may be able to find that there is some form of life living beneath the ice crust of Europa. So I think that's pretty cool. And I know that there's a mission to Europa called the Europa Clipper, which stands a chance of locating, number one, a place to land, and then there'll be a Europa lander that follows up that actually goes and does the landing. But bring this to the forefront of your mind. If we go do that, do we have a right to do that? What if this is a location where there is life? Could our visitation to this gas giant world cause problems? Let me show you that gas giant, by the way. I mean, could that cause problems for the life that's evolving there? Do we have a right to do that? There's a tendency to think that this is our solar system. But what if it's all of our solar system? And what if there's an issue with carrying out these types of things? You know, we don't know.
Yeah, that's deep. And back to Europa, the potential for life under that ice crust, is that liquid water? Has that been established?
Yes, it has.
Okay.
Yeah. No, there's a problem. Okay. No, but beneath the crust of an icy world, there's a few things that can happen. The water can certainly be just wonderful, you know, and beautiful. Okay, but the water can also be very acidic, you know, and that could be if there's a lot of oxygen in the water, because oxygen would tend to make the water more acidic, and that could be a problem for life, you know. Hey there, Giselle. How are you?
I've heard a similar argument about water on Mars. You know, they say they think there's water underground on Mars.
Yeah.
But they believe it has a chemical called permanganate in it.
Yes.
Which may be poisonous.
It just might be.
Yeah. To life as we know it.
Yeah.
As we know it.
And, yeah, and we could be poisonous to life as we don't know it.
Yeah. Oh, exactly.
Right? That's a possibility.
Yep. Well, we've talked about this before on SkyTour Radio and such. You know, it's an ethical concern, and I'm sure greater minds than your or mine have pondered this. You know, do we have the right?
Yeah. We have clouds, as you can see.
Yeah, and as Bernie Dodge says, you know, the prime directive should apply.
You know what's funny about that, Bernie? The prime directive was created by humans, right, for Star Trek.
Yes.
But it turns out that that's exactly how we treat it anyway. To give you an example, the Juno probe that is orbiting Jupiter's poles, is giving us unprecedented views of the planet Jupiter. But the Juno probe, that's Juno, in case you want to look it up and didn't know how it was spelled, the Juno probe is actually powered in such a way that it could cause contamination to a world that it might crash on. So at the end of its life, the plan is to take the Juno probe and plunge it into Jupiter's atmosphere at high speed. This will prevent it from potentially hitting Europa and polluting a planet, or a moon rather, that has the potential for life. So we think about this quote-unquote prime directive thing quite a bit, even though we think of Star Trek as fiction. Is it really, though? Are we not living as we should and considering what it might be like to be on that planet, to be an alien species on a planet that's being invaded? Because we'd be invaders, wouldn't we?
They did the same thing on Saturn at the end of the Cassini mission.
Mm-hmm. That's right, because they didn't want to take the chance that it would ever strike Titan. Because Titan has a lot of gravity, and that it could pull it right down into the, gravitational well, as we call it, the gravitational field, and that could be a problem.
So it was controlled descent into terrain.
And essentially correct, but there's no terrain, luckily.
Well, yes.
Yeah, I know you know that, but
Right.
Yeah.
But if you look at our history on this planet, we haven't been very good stewards.
No, we've had our issues. Hey there, Charles Smar.
But to look on the bright side, maybe this is another chance for us to,
Yeah. Look at that.
do the right thing.
Yeah, this is beautiful. This is just a beautiful view of Jupiter and Saturn right here. And this is their actual placement in the sky, and I cannot believe that we were able to pull this off when it was fighting clouds. It was snowing this morning, by the way. And now
then you don't want to hear that it's 80 degrees right here where I am.
I'm sorry, Carol. Your signal's getting weak.
Okay. Bye.
Carol.
Breaking up.
She's breaking up. Yeah, it's funny. Yeah, but look, this is something you guys have not seen in your lifetime, right here in front of you, right there. You haven't seen this. Here it is. I feel proud to bring it to you. I mean, we tend to bring we do tend to do a lot of firsts. I don't know, for those of you that might remember, we covered the lunar eclipse January 2019. Daryl, wasn't it?
Say that again. I'm sorry.
The eclipse, January 2019, was it? Was that when we were looking at the lunar eclipse?
Oh golly, I think so. It was early 2019. Yeah.
Yeah. Okay.
Sometime in the winter.
Yeah, it was January for sure. Okay. The reason I'm saying that though is we were looking at it and we had the moon, and you could see the moon. The moon filled up a space about this big in the view. It was a full moon, of course, because that's the only time you can get lunar eclipses. Okay, because then it's on the other side of the planet, our Earth, where it can go in our shadow. And the moon was...
Syzygy again.
That's right. The sun, the Earth, and the moon. When any three bodies line up directly in line, that's the lunar eclipse situation. And down in the lower left of the moon, which is over here at that time, when the moon was this big, it was that beautiful dark red, blood red. And up at the top, it was a little bit lighter because it wasn't a full, total lunar eclipse. It was just a partial, but a really deep partial eclipse. And I saw it and didn't know what I was looking at, but I suddenly saw a white flash on that, right in the middle of that red spot, that red area on the moon in the eclipse. And we dismissed it as a potential artifact, but I stored the time and we went back. It turns out, at that time, we, along with only 5 other groups on the planet, witnessed a meteor striking the moon during that lunar eclipse. So you see, it pays to look up.
It really does. And that's pretty darn dramatic. Mm-hmm. And of course, does that, I want to ask rather than make a statement here, Does that particular video, is that still existing in the at YouTube SkyTour LiveStream?
Absolutely. You go back.
Okay, then.
And it's even listed along with the time of the impact on the SkyTour LiveStream page. And in fact, for the title of that. So it's a lunar eclipse, but then you actually see you see the time that the impact occurs, and you can actually watch the meteor hit the moon. I mean, it's
Give me
just
a moment. I'll try to find that.
Thank you.
Swell.
Very good, Daryl. Thank you. Here's a live view, folks. For those of you watching, if you haven't subscribed to us, please do, because this is the kind of stuff we bring you all the time. We bring you live views of the night sky. We take pictures. Our telescope this particular one is in Connecticut. We have another one going in the Arizona desert. And we'll have 2 observatories with which to bring you the amazing wonders of the night sky. The desert observatory actually doesn't suffer from light pollution. So we have some here, but there will be none there. And the skies is astonishing.
Go ahead. I'm so sorry.
No, you're fine.
Okay. I was just going to say that on the Bortle scale of light pollution, or I'm not sure exactly the phrasing, you guys out there will have a Bortle 3 to 4. Is that correct?
Yes. Let me explain that to folks.
Yes.
For the astronomy folks, pardon me for being, for boring you with this, but a lot of people here don't know what a Bortle scale is. That's B-O-R-T-L-E, Bortle. The Bortle scale is a methodology for deciding or calculating how bright the sky is at night. You obviously want a Bortle of 0. That's what you want. That's the absolute darkest possible skies. But if you're at a Bortle 0, you're probably also lost from civilization, and you're probably not going to survive. So I can do without the Bortle 0. However, Bortle 9 or 10 basically is the inner city, and you look up and you can't even see what's going on, so anyway, Bortle, it actually might go from 1 to 9, and then 0 kicks over into the brightest and useless. So 1 is the best, and we are at a 3.5 or so in the desert. Now you might say, why wouldn't we just go to a 2 or a 1? We only had to go about 30 miles more west to go to a 2 or a 1. However, the reason we did it is because where we're located in the desert, we have infrastructure. We have, right out of the gate, we're going to have satellite internet, we're going to have power, water. We have everything we need in the desert because it's on the property belonging to a scientist, dear friends of mine. And these people basically said, you can put an observatory here, sure. And we have an agreement about it and so forth. And I think that's just amazing. So that means we're gonna have perpetual use of this flattened 5 acres of land right out there in the desert. And who knows, maybe we can put up more observatories out there in the future. I don't know. Or somewhere else. I just think that it's a beautiful, beautiful location. Okay.
Amanda says she's ready.
I saw it.
And I'm here.
And she's there.
She's there.
The center of the invite.
Hi, Amanda.
Timing is everything. Hi,
Folks.
everybody. How are you
Hello,
guys?
my dear. How you doing?
Hi, Carol.
So
I'm well.
folks-
How are you guys?
Good.
Doing
Extraordinary.
And just
Good.
for people to understand, Amanda Curran is my regular co-host on SkyTour Radio on kgraradio.com, along with Daryl Mason, who's here. Carol Carl is the host.
She's so
of,
good. She has her own show.
She is.
Oh, yeah. Well, that.
Yep.
Jeez.
And her show
I'm
is on
blushing.
Friday nights at 7 p.m. on kgraradio.com. It's called Behind the Obsidian Curtain, which is a really intriguing name, by the way. And Carol, you're going to have to tell us how you found that, or name, or how you decided on that. But our show is 8 to 10 p.m. on Sunday nights. And we may be moving our time, but I'm not sure yet. I'm working on that. So anyway, KGRA Radio, if you haven't heard of it, it's kgraradio.com. It's got a lot of alternative radio on it. However, we reach, with KGRA, our reach is several million people a month. So we're actually reaching quite far into the ether of the netherworld of radio space. So we really enjoy that. We know that our show is making a difference. I hear people tell us about it all the time. Carol, on the other hand, she's got Friday nights at 7 p.m. locked up, sewn up tight, and she has fantastic guests. I'd like to actually hear about the one you were starting to tell me about earlier, Carol. You did an interview with someone that you said was fantastic.
Well, you know what? They are all fantastic, and that's one of the treats. It's kind of like, I don't know, if you ever been to a party and there's somebody there that you know something about, and it's kind of like suddenly there's this one-on-one conversation. That is the joy of interviewing these people. A lot of them, are, shall we say, notables in the field of paranormal and ufology, etc. But I'm not really sure which one which one of these Incredibles you're referring to, Mark.
You said you had an interview. Was it last week?
Last Friday was Tracy Austin, who has her own show on KGRA on Sunday nights. Okay. She is, I don't know what to say about her. She trained in England as a concert pianist, and then was a teacher, etc. And she has had some absolutely, her sightings of something in the sky were confirmed sightings by others. And she took that. The BBC eventually picked up her sightings, and that was her first foray into television. She's written a book. Her latest book is, let's see if I can pull the title out of my fevered brain. It was, I should have it right here, but of course I don't. That's too easy. Here we go. It is I Survived Beyond and Back, True Accounts of Near-Death Experiences. And yeah, that is her book that will be published sometime this month.
Wow.
Yeah.
That's pretty cool. I kind of know what that's like.
Yeah, I was thinking, yes. You came to mind during the interview, in fact, yeah.
Well, it's a interesting subject matter, I can tell you that. We're still waiting for clouds. It comes and goes, but I'll make an effort to check and let you all know when that changes. But right now, this is the photo that we took just a few minutes ago. Actually, it's beautiful. And before it was actually dark, I started taking other pictures through the clouds, and here's one of them. Okay, so it was light clouds that I was photographing through, and we should have been able to see Jupiter's moons by this point, but it's just not possible when you're going through clouds and it's still this kind of light out, But I think that it's a really amazing view, and this is another view that we took earlier, and this view was done so that we could actually see the separation between the rings and the planet, and also see cloud bands on Jupiter. Jupiter is big and it's bright, so getting the cloud bands on Jupiter and seeing the separation between the rings can be tricky. So this was the result of a few attempts, but this is good. I do think that this one probably is one of the better ones for the evening so far. Well, maybe not this one. Well, there's another one that we did. Let me just do some processing here I sharpened this one up a little for you so you can see, and there you go. That's what it looks like in the telescope. Isn't that incredible?
Oh.
Wow.
I love the colors.
Yeah.
Is that a filter or?
Yeah, this one's using the narrowband 2 filter, which is, I have to describe that, by the way, so that you guys know. The way it works is, if you take filters through the sky or into the sky, and you don't use a filter, then you get whatever's in the sky, which could be light pollution, clouds, and so forth. If you want to cut through some of that, then you use filters. The filters we're using here are narrowband filters. This filter right here, if you imagine, if this is the spectrum going from left to right here, okay? So we go from, say, red to blue, okay? Red, orange, yellow, green, blue, indigo, and violet. That's the visual spectrum. It's what your eyes see. Well, if we take only narrow slices through that spectrum and only allow that light to come in, then that's what's called a narrow bandwidth, a narrow band pass. That's what these filters are. So this one we're using here is just a little bit wider of a band pass, right, than the other filter we have in here, which is a very tight slot through the spectrum. And that slot through the spectrum with a very tight one is 4 different filters all in one, basically. This filter we're looking at is 3 different filters all in one that take very special places in the spectrum that give us the best and finest detail. And this is what you get, you know. So that's what we use, and where we see them is in our telescope control system. If we come back here briefly, down here on the lower left, this right here above my head, you can see narrow band 2, okay? Now if we go to narrow band 1, that's going to change the view, but I have to first see if we actually have anything to see. And right now it looks like we have clouds right now. So we don't have the live view. This was the live view from before, as we said. Just beautiful. But this is exactly the view that I was hoping to get tonight. Very, very happy to see this. You know, just so nice. Hey there, Simcoe. How are you?
And just for new people joining us, this is the night where the conjunction will be the closest, but you will be able to see it for a few more nights, right?
Yes.
Yeah. Oh yeah.
Okay, so people in the West Coast can still see the conjunction now, but more on the East Coast is probably already set.
It's 5:49 Eastern time. It should still be visible. Depends on your horizon and trees and terrain and stuff, but it should still be up.
I'm showing you right now, actually.
If you have a dead flat southwestern horizon, your local time, whatever, it should be visible until maybe around 7 p.m.
Okay, right now, Jupiter and Saturn, if you look here, this is the live view of the telescope control program called Stellarium that we're using. And you can see Jupiter and Saturn are here, and they are right now. If we click on Saturn, all right, you'll notice that its altitude is only 8 degrees above the horizon. All right, so it's actually quite low. So the fact that we got as good of images as we did earlier was really special. Really special. Hey there, Christian Engelhardt. How are you? And Keisha. It's so nice to see you. And UC Baltimore, what's going on?
And Christian asks, will they collide?
No, you know what, Christian and Daryl mentioned this the other night too. When we look at Jupiter, we're seeing it 500 million miles away from the Earth, okay? When we look at Saturn, we're looking at a planet that's 1 billion or so miles away from the Earth. So there is 500 million miles between the two of them, but Saturn's in that direction, farther into the page, away from Jupiter.
Yeah,
so,
they're along the same line of sight. They are not physically close to each other.
Right.
Yeah, that's correct. And that brings us to Daryl's favorite word we talked about before, which is syzygy, and that, as Daryl has often defined it, is when you have 3 or more objects that form a straight line in space. And so here we have Saturn approximately with Jupiter, and us approximately. So we're making an effective line. But that doesn't last long. In a couple of weeks, this will all be over. So we still have a few days. I will say this, though. Tonight is the very last stream of the SkyTour LiveStream from Connecticut. The next time we go live in another couple of weeks with the Observatory, it's going to be from Arizona. So this equipment is getting packed up and shipped to Arizona this coming Saturday. So I wanted to show you all this because I wanted you to see this amazing conjunction. Okay, and we still have clouds in our main view here. We didn't before, as you can see. I mean, we looked at these others. These views came from earlier tonight, and then we took a deeper photograph, and what we could see were not that particular photograph, but a deeper photograph, we could actually see the moons of Jupiter. Okay, this is Europa. Sorry, that's not Europa. This is Europa. This is no, that's a star out there. These are the Galileans.
Yeah.
Okay, this is Europa right here. This right here is Ganymede. This is Io, the closest moon to Jupiter, and I'll explain why it's not closer than that. And then this is Callisto. And the reason that in this particular view that Ganymede is actually closer looking to Jupiter is an accident of perspective. Jupiter's closest moon is Io, and it goes about this far and this far on either side of the moon, on either side of the planet. Ganymede's in a very big circle around Jupiter, and it just happens to be either on the far side of Jupiter or on the near side of Jupiter, and in our line of sight. Okay,
Ganymede is actually going to start transiting across the face of Jupiter in a few minutes, followed by the shadow of Ganymede.
Which I wish it was clear we could see it.
Will it still be up by then? I'm not sure.
Well, it's 9 degrees above the horizon, but at that altitude we may not be able to see it. But we've done this before. We've actually looked at Io's shadow going across the face of Jupiter from here. And from the skies that we'll have in Arizona, we might actually have a really good view of that as well. And we can watch that again. All right, so
it may be visible here. It looks like it's a little farther away than I thought.
Okay.
Let me see. It's presently 3:53 my time, and the transit begins at 5:15. Okay, so yeah, it's going to be down for you. It'll still be up for me.
Okay.
Still, though, I'll be looking through low elevation also, and probably won't be visible, but just interesting to note at any rate.
Yeah, for sure.
And Ganymede's shadow will be following Ganymede across the face of Jupiter.
Wow, that's good. No, Simcoe, there's no end of the world issue. We're just enjoying the views. This was one of our narrowband filter views of Jupiter a little while ago. This was also a narrowband view. Remove some noise here. Okay.
Per Simcoe's question, astrologers might make a big deal out of this. Well, some of them I know are making a big deal out of it. This kind of goes along the line of thinking of why they call it a great conjunction, because it only happens once every 20 years. Not that I believe in astrology, but I know some people do. And they're saying this is a time of great change, like sort of from the old to the new. It's like the beginning of another cycle.
Yep.
What that portends ultimately, I don't know, but fasten your seatbelts, folks.
Well, just to keep in mind, just one question. I'm sorry, Amanda, I'll let you go in a second. I'm just going to make this statement here. Just so everybody knows, what we're seeing, the event that we're here to look at tonight is this. You're looking at it. It's Saturn and Jupiter being very close to each other. Now, this isn't close to each other physically in the sky. It's the apparent line of sight to us, okay? We know that it's Mercury, Venus, Earth, Mars, Jupiter, and then Saturn. Then Uranus, Neptune, and yes, Pluto's a planet, darn it all. That's my feeling. Okay? But Jupiter is 500 million miles away from us, and Saturn is yet another 500 million miles away from Jupiter. So it's making it 1 billion miles from us, 500 million miles from us. So it just so happens that Saturn and Jupiter are crossing each other's path in the sky, but they're very far from each other. Okay? So when they cross in front like that, like you see them like this, one's way far away and one's right up close a little more. So that's what we're seeing. It's a perspective effect. Note also that when we look at Saturn, I mentioned this before, see the ball of the planet, that round ball? That's just slightly smaller than Jupiter. But why does it look so small here? It's because it's that much farther away. Okay, so that's what it is. I'm sorry, Amanda, go ahead.
I hate to say it because I just got here, but I am going to have to go.
Okay.
No.
I'm sorry.
That's
I
okay,
am,
Amanda. That's fine.
Needed elsewhere, but this was beautiful. I'm glad I got to see a bit of it anyway.
Yeah.
It's raining now. It's been raining all year here, so I never get to see anything, but this is wonderful. And I didn't realize this was going to be the last one from Connecticut. Wow.
Yes, because the telescope equipment is being picked up Saturday morning and being driven out to Arizona. However, right on the heels of that disappearing from the building, I'm taking the dome down and going to replace it with a roll-off roof observatory like the same one we have in Arizona. This gives us the opportunity of fully automating both sites, and that's the beauty of it. This one's automated except for the dome. I'm inside my visual effects shop, in my office, running it from here. And so doing that from here is very beneficial, as you know, because there have been times when I've been out in the dome running it in the beginning, and it was very cold, like 15 degrees in the dome, and I'm like, this is Orion, very cold. Yeah.
Send some heat my way when you get there.
Yeah, I think you need clear skies, actually. But thank you so much, Amanda, for coming. It's really nice to have you on board, even if only for a little while.
I know. I'm sorry. I wish this was better timed.
Fine.
I didn't know you were actually doing this until I got home and you were doing this. So
you know how it works.
Just bad timing. But glad I got to be a small part of it, and I hope everyone out there has a wonderful evening. I hope the clouds stay away for you guys, and I'll see you guys later.
Okay.
Yeah,
Happy Christmas in case I don't talk to you guys later, but happy Christmas, everybody, or however you celebrate.
Okay, well, thank you for flying Southwest.
Yeah.
Okay. Good night, guys.
Thank you
Good
for
night,
joining
Amanda.
us, Amanda.
Night, Daryl. Night, Carol. Bye.
Good night. She is the queen of multitasking these days.
She is
very
actually
much in demand. Amanda Demanda, right?
Ooh,
she is
good.
in demand. Yeah.
Yeah, and I mean, I can't remember if it was you or I that coined the phrase, Daryl. Amanda Astronomy, was that you or me?
I think you did.
So Amanda Astronomy, that's another thing, because I talked to folks the other night about Amanda on our radio show. She gets embarrassed, but the fact is, when we're doing a radio show, you can't help but pick up things. And Amanda didn't know anything about astronomy when we started. Nothing about astronomy. She knew that the stars were out there. She didn't know what they were. Not really. Well, she's come a long way in the couple of years that 3 years that we've been doing this. Okay? And that's on SkyTour Radio, all right? On SkyTour LiveStream, I found that she'll actually interrupt me to finish my sentences sometimes, to tell everybody about the things that we're looking at. And you know what? I like that. I don't get angry. It's like, I'm talking. I don't do that garbage. This is, to me, it's the greatest measure of success that you're having with someone when they can turn around and finish your sentence for you with the right answer. And she does that sometimes. And I'm like so proud of her for doing that. She's a really good person. So, and now, this is to I don't know how to say your name. What is that? You got a couple.
Don't either.
You got a delta in there, an alpha, and a couple of lambdas. Now, what is your actual name? I know the Greek alphabet, fully, because in astronomy we need to. But if it's clear tomorrow, we're gonna unfortunately be taking the equipment out of the dome and packing it up. So we're going to be back online very soon. In fact, the equipment is going to be at the observatory site on the 30th of this month. It's going to leave here on the 26th, and it's going to be there 4 days later. And it's going to be monitored every step of the way, because it's being taken by another streaming group that are going out there and that are going to share our observatory, because I offered them a pier in the observatory to use, and they will have the ability to stream from the dark skies as well. These dark skies should not be kept from people, I'm telling you. We have enough pier space for 3 different telescopes, and we're going to put mine in there with the SkyTour LiveStream. We're going to put theirs in there, and then we're going to have another one of ours that is going to be, as I mentioned earlier, the wide field scope, which is going to take in panoramas of the night sky. I mean, we're going to have about a full degree of field to look at, maybe a little more. And it's just beautiful how this other telescope works. So happy with it. Hello, Fernando.
You'll be out there for New Year's Eve, will you?
I probably, maybe, I'm not sure. I don't think so. He'll be out there.
He will.
Yeah, I'm not sure I can go there in that time.
Yeah.
You know, but I want to say hi to Fernando from Brazil. Welcome. Thank you for joining us tonight. It's very happy to see you. Make sure you subscribe. SkyTour LiveStream right here. Just subscribe and hit that bell, because we do this kind of stuff all the time. Our live astronomy sometimes captures the most amazing things. And you're welcome to join us. Everybody's welcome. Oh, and these pictures that we get, they all go up to our Facebook site, SkyTour LiveStream with Mark D'Antonio, and you'll find the raw data up there too, most times, and you'll find the processed photos up there. So while we're waiting for the skies to clear, and I can see that they have not yet, and they probably won't clear in time, but while we're waiting, what I'd like to do is to just spend a little moment showing you some of the things that we do in SkyTour LiveStream, so you can get an idea of the kinds of things that people see when they join us for our nightly sky tours. All right, and if you want to see, then that's great. I mean, you can always join us anytime you want. I'd love to have you.
There are 400 watching right now, Mark.
Fantastic. Thank you, guys.
Yeah.
Make sure you subscribe.
All right.
You got to subscribe, man. Make sure you subscribe, and then we'll have a beautiful the more people we get, you know, then the more opportunity I get to do better things, you know, because what I want to do is get people to sponsor us. And once we get the sponsorship of, say, a group of people or a foundation or a business, then I think that we'll be able to take this to the next level. This is astronomy for the masses. And honestly, people that know me, I could care less about the glory and so forth of this job. All right, I'm an astronomer. This is what I do, and I can't help but look up when I go outside. And I literally have to be careful when I'm driving and there's a sunroof in the car at night, because I'm whoa, I'm looking up because I'm always trying to see the coolest stuff out there. Always trying to see what's going on. So I guess that's a little bit of a problem, you know. But let me just I'll just show you some of our things that we've done here before. First of all, okay, here we go. This right here. Okay, this image right here. This shows us, or shows you. This is the sky overhead here. I took this image out here on the front lawn and looking up at the sky. So we have light pollution, but it's not that bad. Okay.
I see the North American Nebula, I think.
Right there. Yes, you do.
Yeah.
The North American Nebula is right here. This is Cygnus the Swan. Okay, it goes down like that and across like that. This is a summertime sky. It's beautiful. You know? And then, you know, this is a globular cluster, of which we've seen many, these individual stars. Like with Messier 13. This is Messier 13 right here. This is the Great Cluster in Hercules. And this particular cluster was the subject of a rapidly moving signal sent out at the speed of light from Arecibo radio telescope down in Puerto Rico. And this signal was something called the Arecibo signal. And it was sent to Messier 13 as a proof of concept. And it was sent to send a signal to any alien species that were out there. That, hey, we're here, this is where we are, this is our location. And in the signal was encoded our location and some details about us. Pretty cool. So, here's a galaxy that we took. This is called just the black eye? No, sunflower galaxy, I believe. Yes, it is. This is a sunflower. And then This is a beautiful nebula. This is called the Christmas tree cluster up here. And this is a reflection nebula, beautiful blue nebula. And this is the cone down here at the bottom, a star-forming region, a molecular cloud. Absolutely incredible stuff out there.
Nice picture.
It is a beautiful picture, yeah.
In Monoceros, the unicorn.
That's correct. Absolutely right. Daryl knows his stuff.
He does.
This is a nebula that I took a picture of that actually has a satellite that was tumbling as it went through. And you can see how it would be bright and then go away for a minute, then be bright and then go away for a minute. That's what happens. You get these kinds of weird things. This is not Starlink. But, really cool. This is something called the cocoon. And you'll notice it has this red, beautiful red color. That's because the hot stars in the middle of this are ionizing the hydrogen gas, which is out here. You'll also notice that there seems to be like a dark mass blocking the stars behind it. And that's exactly what's going on. This is a dark nebula. We see these in SkyTour LiveStream as well, and they will show up even better in Arizona. So there's so many things that we want to see when we go out there and start handily taking apart the sky for our own perusal and so forth. And we will do it. We will do it with all of you, So hopefully...
That's so exciting to think about.
Oh, it is. It's it's very enjoyable, I really would like to see that, I'd love to see that the folks that have joined us are going to spend time with us again. What I have to do now, I can see that I'm getting some red in here. That's actually the dome. But I don't believe that we're going to see the planets anymore tonight because it has become cloudy. We squeezed this out, man. This was incredible that we actually were able to get this visual tonight. Really, really cool.
Timing is everything.
It is indeed. And this is probably one of the best shots right here. This was Jupiter down here with its moons. You can see this right here is the moon Europa. This right here is the moon Ganymede. This right here is the moon Io. And then this out here is the moon Callisto. Okay. Now, I did take some brighter images of it. But, just for the record, we wanted to show some of the detail on the planetary surfaces and cloud tops.
Right, and Charles Marr's question would fit in, I think, right about here. Mark or Daryl, could you explain that Jupiter and Saturn are on different planes? He thinks the separation is 1.5 degrees.
Yes. May I?
Go right ahead, Daryl. Thank you.
Yeah, Charles. They are close to the same plane as Earth's plane around the sun, orbital plane. But all the planets vary a degree or two. When you see that plane up in the sky, that's called the plane of the ecliptic. I sometimes call it the highway in the sky. That's the path that strictly speaking, the ecliptic plane is the plane of Earth's orbit around the sun. But broadly speaking, it is close to the plane of most of the planets in the solar system. Only Pluto is not really close to the ecliptic plane. They vary by a degree or two, but when you look up in the sky, like tonight, if you go out and look and your sky is clear, you'll see, if you know where the sun set on the southwestern horizon tonight, that helps define the plane. And from there, if you stick your finger, point at Jupiter and Saturn at arm's length, and we'll point it at where the sun set first, and arc up to where Jupiter and Saturn are, and continue that arc across the sky. Not a straight line, but it's like a great circle across the sky. You will see Mars farther over to the east, the bright red planet, and you'll see that the moon is also close to that plane. They do vary a little bit, and Mark might chime in on this, but I assume variations in their location, close to or not to the sun, except in Pluto's case, might be due to planetary impacts at some point in the past.
Yeah, I mean,
Bart?
Jupiter. Jupiter is sort of like the shepherd of the solar system in that its gravitational force is the strongest. But what we notice is that in our solar system, right after Mars, you have this gap, and then you have Jupiter. But in that gap, we have the asteroids, right? Why don't we have another planet there? Could we have had another planet there? Well, the answer is not likely, because Jupiter prevented it from happening. So what happens is, as Jupiter goes around the sun, all right, you have all these asteroids. Now let's suppose early on in the solar system, when everything was forming, you had all these rocks, and they would collide and coalesce, and their gravitational force would end up clumping them together, and they could end up becoming a large mass, like a planet. That's how it happened everywhere else here. But as Jupiter went around, Jupiter's so massive that it kept pulling on those rocks and dislodged them a little bit from the orbit. So as Jupiter went by, like for instance, the asteroids are here. Okay, the asteroids are going by Jupiter because they're inner more, and they're going faster. So as they pass by Jupiter, this happens. Okay, see what's happening? My fingers are each an asteroid. As Jupiter is in the outer solar system here, as the asteroids start to pass by it, they get tugged toward it. So you get this little wave, okay, of the asteroids as they move by Jupiter. And that little wave constantly for millions and billions of years prevented the asteroids from ever forming one cohesive planet. Now people say, we've got a lot of asteroids. Yes, we do. There's quite literally millions of asteroids. But if you add up all their mass, you ready for this? This might be something you may not believe. If you add up all the mass of all these asteroids in our solar system, they equate to only something about a quarter the size of the moon. Okay? So even if they did coalesce, then they would only be something that's just under the size of a quarter of the moon in mass. So it's really not that much stuff in the end, is it? If it was a moon-sized asteroid belt, I suspect Earth might have been pelted in the past by a lot more giant impactors. You know. Thanks, Jim Donahue. You were right. I had my cursor in the way. I apologize for that. You know, and I'm sure it's better than
along that
me being
line,
in the
you
middle
might
of
add that I will add that when you look at that highway across the sky, the ecliptic plane, where all the planets run, more or less, you will see the moon close to that plane, but the moon's orbit is tilted to the ecliptic by 5 degrees. This is one reason why lunar eclipses and solar eclipses don't happen every month.
Yes.
But in the moon's case, it was almost surely a large impact that skewed the moon out of Earth's orbital plane around the sun, that highway in the sky. Sometimes you'll see it north of the plane, sometimes you'll see it south of the plane. But it's tilted about 5 degrees, and that's about 10 lunar diameters.
Mm-hmm. Yeah, and you know the thing about this is that for all the regularity that is in our solar system, it was born of a lot of chaos. And what happens is the universe has time on its side. And the time on its side means that it actually has the ability over time to let things settle out. Because all the interactions, all the gravitational forces, all the collisions happen, and then things settle out. That's why we have a single moon around the Earth. We may have had a ring, and then once they all coalesced into a moon, then they ended up forming the two bodies that we have, the Earth and the Moon. Now, the interesting thing about the Earth and the Moon is they're not done interacting, okay? Because as the Earth rotates pretty fast, okay? The Earth rotates every 24 hours. The Moon rotates once a month because it's tidally locked to the Earth, right? Meaning it has the same face looking at the Earth. So as it goes around the Earth, okay, if you looked at it from above and paid no attention to anything else, you would actually see the Moon rotate once a month, okay? So as the Earth spins, the Moon is pulling on the water on our planet, making a tidal bulge, right? But that bulge is being dragged forward a little, and sticks out a little bit ahead of the Earth, okay, as the Earth is rotating. And so the moon is feeling a little extra force in that direction where it's going. That gives it a little extra oomph all the time. And that drag that the bulge is causing on the Earth is slowing down the rotation of the Earth. You ready for this? The Earth used to have a 5-hour day. How about that? 5-hour
Wow.
day. But over time, all right, it has actually slowed down tremendously in its rotation rate because of this drag. All right. So we went through an 18-hour day, then a 20-hour day, then a 24-hour day where we are now. But here's what's happening. Because the moon is actually gaining a little bit of speed over the centuries, it actually amounts to about 3.8 centimeters per year, that it's actually getting a little farther away from us. So slowly but surely the moon is spiraling away from the Earth. And if the
conservation of angular momentum.
Exactly where I'm going. Exactly right. It's something that, in physics we do call it, as Daryl said. And now what happens is that means the moon is spiraling away slowly from us, and the Earth is slowing down. Now eventually, guess what's going to happen? If left alone, the Earth and the moon will become tidally locked to each other. Left alone, because the Earth is in the process of tidal locking to the moon. That means that, just like Pluto and Charon, just like Mercury and the Sun, a little bit. Mercury and the Sun aren't quite tidally locked. It's a little different. And just like the moons of Jupiter, the Galilean moons, okay, they're all facing one direction as they rotate around because they've tidally locked. All right, and that means that now they will face each other, forever and go around each other forever. Well, the Earth and the moon eventually, if the sun would last forever, the moon and the Earth would end up doing the same thing. And to see dark skies, you'd have to actually travel around the world to the spot where the moon wasn't, because it would always be in the same relative spot above your head. And that's just no fun.
No fun at all.
Not for astronomers.
Ian Kendall just pointed out, not to interrupt you, that the viewing numbers have escalated. It is now 668, Mark.
Oh, fantastic. Fantastic.
Yikes.
I see that.
Yeah.
Now, folks, just to let you know.
Welcome, everybody. Hit that subscribe button.
Yeah, please. And
ring the bell.
And ring that bell so you see it. I was showing you some objects we've taken before. I'm going to show you another one. This is another object we take in SkyTour LiveStream. This is a very, very famous nebula. You can see this right here. It's really dark, but it's called the Elephant's Trunk Nebula. And it's something that is in our northern sky. We'll still be able to see it from Arizona when we get there. But it's just a beautiful object. And we process these images to show you these things, okay? Isabella Melamed in the chat is someone who also does processing, and she does phenomenal work. She's learning, and she's doing a great job. I just want to compliment her here publicly, so everybody knows, Isabella from Bulgaria, that you are doing a really good job.
She's amazing. She's an animator.
That's right. Amazing job she's doing. Okay, so going back to our view then of Jupiter and Saturn, this configuration is going to remain for a few days, a little bit more. So what I would suggest to you guys is you go outside. Daryl said this to you before on our radio show, and look up, or as Captain Kirk would say, Spock, you've got to look up. If you don't, you'll die. So basically you've got to give it a shot. You got to check it out. The
more you look, the more you see.
That's very true. That's exactly right.
Folks, I answered this in chat for somebody a few minutes ago to expand on what Mark said. No matter where you are, go look. If your skies are cooperating, start looking 15 to 30 minutes after sunset. Jupiter will be rather low above the southwest horizon. Jupiter will be the brightest thing in that part of the sky after sunset. It'll be a bright creamy white color. If you have binoculars that will help, you may see more if you have a telescope and can get it set up. But you'll see Jupiter first, and as dusk grows, you will see Saturn come into view just above Jupiter. And you may have, if you see it, say at 5:30, if you have a good flat southwestern horizon, it should be up there until roughly 7 o'clock, depending on where you are in your time zone.
Yeah, exactly. That's really
no matter where you are.
Yeah, and thank you, Daryl. So this is the kind of information you get from us guys. You know, I was just checking to see what was going on, to see if our skies were back, and they're not. So I think we're clouded out for the night. But I will say, we did get some really nice views. So we did capture this. I'm really happy that we did. I'll make these images available as well, and you can play with them and monkey with them all you like. Again, just before we move along here, I want to share with you one more shot. This one that I'm going to show you now, this is another one that's a favorite of ours, and it's a favorite of Isabella's that we talked about, because she actually got one of these and blew it up in a large, made a large image out of it. It's this guy right here. This is called the Bubble Nebula. Isn't that pretty, Daryl? That's just beautiful.
It is.
Yeah, and this is the way this. See, we took this photo right here in the observatory, and this bubble you see right here. Traditionally, we could only see this part of the bubble, but I've learned and used a new technique to capture more data than ever before, and been able to do it in such a way that we can then get rid of the noisiness that occurs in the imagery. Okay, in the middle of this nebula is a star called a Wolf-Rayet star. Now, what are those? Well, WR stars, Wolf-Rayet stars, are very, very hot, and they actually sometimes pump out their whole outer atmospheres of hydrogen gas, and it's a precursor to going supernova. So this will be a supernova site at one point. Now, this is a very hot region, and this bubble is expanding pretty uniformly away in this direction. But over here, you see, it's collided with some knots of stuff. So it's done some other weird things as it gets slowed down. You know, because this stuff moving out from a star is like a snowplow trying to push out. And when it actually makes its way outward, it collides with other stuff, which excites it and makes it actually start other star formation along the way. The universe is a phenomenal, amazing place, and I love being able to share with people all the things that happen out there. And the nice thing is, we don't know the half of them, and we think we're advanced in our science, but I can tell you that there's times when we're not. Now, I'm an astronomer. It's what I do for a living, okay? But I can tell you that I don't know everything. I just don't. You know, we'll take stabs, we'll try to figure something out, but honestly, I don't know everything, and there's no astronomers that do it. If there is one that says they know everything, turn around and walk away, and just go, and walk away, because no one knows everything. If anything, the universe has humbled me beyond measure, because everything I see in the universe, well, be honest, everything I see in the universe is trying to kill us. Okay. Let's be clear. The universe is trying to kill us everywhere we go. But you know what? It hasn't succeeded yet. We've had asteroids strike us. We've had volcanic eruptions on the Earth. And I've talked about this in SkyTour Radio on kgraradio.com. On SkyTour Radio, we've talked about the fact that the Earth is a habitable zone world. We can have liquid water on our surface. We survive. We're carbon-based creatures. Look at me. I've got all my DNA cramped up in here. And we're fine. Except the Earth is not the best location for humans. Not the best location. It's really habitable, but not super habitable. And we found worlds, and exoplanets are my specialty in astronomy. That's where I've gone with my astronomy. Planets around other stars. Some of them are super habitable. They are better for us than the world we're on. The world we're on, okay, suffers from ultraviolet light from the sun, which can give you skin cancer and all kinds of things. We suffer from tectonic activity, where We have earthquakes, and we have volcanic eruptions. These take lives. They spew things into the atmosphere that can be tough on the lungs, especially if there's a big eruption. People with asthma can be killed by a volcanic eruption that's occurred 1,000 miles away. Is if this volcanic ash gets into their lungs, because many times it's like microscopic particles of glass, and that's really harsh on humans. So there's a lot of reasons why the Earth isn't good for us, yet it's all we've got. It's all we know. So we think this is the best planet to be. That's because we can survive here. And looking elsewhere in the solar system, like Jupiter, where the cloud tops are, negative 200 degrees, okay, Fahrenheit, or even worse in Celsius, right? And where Saturn's cloud tops are even colder, you look at these things that go on and you say, wow, we're the only habitable world. And we are. Now, Mars can be made into a habitable world. And on SkyTour Radio, we've often talked about ways in which that can be accomplished. So there's a really cool science behind terraforming. And with Mars, we don't even have to touch Mars to terraform it. On the movies, they always show, like when Arnold Schwarzenegger, he was at Mars. Remember? That was the movie.
Yeah.
Total Recall, right? Get yourself to Mars.
That was a dumb movie.
Yeah, you can say.
Fun. I liked seeing Arnold Schwarzenegger get his butt kicked by his pretend wife, who wasn't really his wife, but just a agent sent there to monitor his goings on.
Sharon Stone was hot.
But Mars was cold.
Yeah.
So the funny thing was that when they talked about terraforming Mars, they had this the core of the planet was turned into oxygenated atmosphere, blah blah blah. But see, and they did it in an instant. Okay, obviously that would never happen in the real world. But there is a way to do that, because the reason Mars is not survivable now for us is because primarily it doesn't have a magnetic field like the Earth does. Our magnetic field protects us. It's a sheath of protection around our planet. Mars doesn't have one. So maybe there's a way to show that. Maybe there's a way to do that, and make Mars have a magnetic field type thing. And there are actually mission directives on the docket at NASA to create an artificial magnetic field for Mars. It doesn't mean starting up the core of Mars again, because that's what it would take to actually give it a real magnetic field. It's actually using a property of magnetic fields where they can actually drape behind the source of the magnetic field. If the solar wind is pushing against this magnetic field, it can drape and be lagged behind, kind of like airflow. You push air along and it would actually drape around something. Well, if you have that something be Mars, and you can have a big magnetic field and you cause it to drape around Mars. Mars has a magnetic field at that point. And in just a few years, Mars could then be noticeably different than it is now. So there's a lot of ideas. So it's SkyTour LiveStream. We love to talk about all these different things. Daryl and I and Amanda, we have wonderful conversations, and with people like Carol Carl, who's our special guest for tonight, we have this amazing set of conversations that we have. And I tend to talk a lot, but then again, there's a lot to say. So Daryl usually has to interrupt me, and Carol Carl has to usually say, "Shut up, please, I have to talk." And, something like that.
No. The way you listen, the way you explain, and you make it educational and fun. There's that factor there. It's compelling stuff.
Oh, but for the folks that are first time here, I knew I was going to be an astronomer when I was 9 years old, and I never wavered. And my parents always said, "Why don't you get a job where you can make some money?" Well, they were right about that. Okay. So I decided I had to be an astronomer because I had to know what was going on up there. I look up and I say, "What is that?" I was a kid. And I learned what it was. And then I went on, and it just this snowballed. I've used some of the biggest telescopes and some of the best observatories. Okay. And I can tell you that I've never lost the fascination. The only fascination I've lost is doing like a midnight to dawn shift in a northern observatory where the temperature drops to like 10 below zero during the night inside the dome. I've lost the fascination with that.
Yeah, gee, I can't understand that.
Yeah.
No.
Yeah.
And while I'm interjecting here, I want to interject that Marcin Johansson and DDB are in the room.
Dee Dee is known as the sniper. She takes away comments that are bad that people make, and you know what? Honestly, we don't have that problem here. You know, and I think it's because people know that we're just, you know, we're not people that are trying to toy with anybody. We're actually trying to share some interesting stuff, and we love doing it for all of you. You know. So
Have
it's
you
nice
taken
to
a
see.
live view look lately, Mark?
I did. I just a couple minutes ago I did it off camera, but I'll do it again.
Oh, yeah.
Yeah. See, we've got nothing. Yeah, right now.
Okay.
Yeah. And actually, if we look at our information here, okay, you can see that. Let's see, Southwest. Yeah. The planets have set already, from our perspective. Actually, I'll show you something too. This is another thing. I'll just maximize this for now. Okay, this is a planetary view. This program is actually free. You can get it online. Okay, and what it does is it allows you to capture the sky, see the sky, just the way it looks at your location. If you put it in, you can set up the time. You can set up your location where you are on the planet. Okay, we are in Connecticut right now, but if you're down here in Africa, if you're up here in Siberia, if you're in Japan, you can just set that setting, and then you can actually get that, and the sky will change instantly to where you are. You can also have these different landscapes. This is cool. Okay, this is a landscape that I'm in now. It's called Garching. Here's Geneva. Okay, and it's then we have Grossmugel here. And if I get this thing out of the way so you can actually see what I'm looking at. Okay, so it's a landscape, okay, that shows you like how things look from that particular location. But guess what else you can do? You can actually put in your own. And I did. I put in this one. This is our landscape. This is our view. Here's our dome. This is the remote telescope dome right here. And this is actually our horizon, you can see. Okay, it's absolutely good. It's a beautiful horizon. And that's actually my house right there. And this is a remote observatory that's about 70 feet out on my front lawn.
Hey, we can see your house from here.
You can see our house from here. That's right.
Yeah.
Yeah. So, you know, if it was clear, we would have taken tonight and gone to different locations in the sky, check out Mars, check out the moon. But unfortunately, it's not clear. I really, though, do want to say to you guys, I want to thank you so much for coming out. There's 645 of you watching. And I would hope that you do indeed subscribe to SkyTour LiveStream. We do this every clear night. And the only reason it's not going to happen for the next couple of weeks is because we're transferring all this equipment that we have here out to our Arizona site. And we're going to go live at the Arizona site next month. So, but I will still be doing other streams from here because I do have another telescope I'll be putting right back in there, and we'll be using that one as well. So we will be going live with our earlier instrument that we had in here. So, in any case, I hate to cut it short, but you know what? We've gone over 2 hours and 15 minutes right now, and you guys have been great. But Jupiter and Saturn, you got to see it. You got to see it here, and you got to see it live. So we are very pleased to have brought this to you tonight. And if you guys have any questions, or you want to get a hold of me in any way, and actually Tommy P has a question. He wants to know what's the name of the software, please. Well, the name of the software is right here, Stellarium. Let me bring it down so you can see it. Stellarium, right there. Stellar IUM. Right? And it is a phenomenal piece of software. And if you have a telescope, you can actually control your telescope with it. We use it to control our telescope, but there's other more advanced systems that actually could be used to control the telescope. And we're going to be implementing those when we actually get out into Arizona in earnest. All right. And on top of these views that you've seen tonight, we also have an all-sky cam, which shows you 180 degrees around the observatory with all the sky. And seeing the Milky Way in that is just spectacular and so much fun. You know, and it's a photo that will capture all the meteors that might come through, aircraft, UFOs. I mean, you know, whatever. It'll capture it. So if you guys are interested in this kind of thing and you want to see this live astronomy, check us out, man. SkyTour LiveStream is right here. You're in it now. Subscribe. I love to see how many people choose to join tonight. It's free, of course, and I don't charge you for anything. And eventually, maybe I'll make a Patreon. I'm thinking about it, but I'm just too busy to get into it. I want to actually show you guys stuff rather than worry about the cash flow, you know?
Yeah.
And trust me, there's been some serious flow here. You know, the instruments, this system here is right now sitting at over $10,000 in cost, and so we're moving all of that to Arizona. And I don't mind telling you, I'm a little nervous about that. I trust the guy bringing it out there. I trust him implicitly. I think. I think.
Yeah, well, you know, he's going to be on top of anything that comes up. The delight is that he knows about the equipment.
Yes, he does. He's very, very good about that, as a matter of fact. So I'm really pleased. And one last time, I do want to run through and say, I want to say hello to Arda Akin, Ashton Backdoe, and Bobby Burgess, and Careless Ray, and Carol, of course, and Charles Smar, Cindy Murphy, you Daryl, of course, DDB, yeah, Diego Brando, Fats, and Gaia Savella's Gina Leone, and and okay, whatever your name is there, I Kiss, okay, Ian Kendall, who's been a subscriber for many years, as he mentioned. I'm glad he's finally able to get back online. Indiana Jones, dun, 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 dun. Isabella Melamed, a friend of ours. James Dugan from Down Under in Australia. Jaron Vonk, nice to see you. Lily K. And Mailers 516. Marco, of course. Martian Johansson, hey there. McGillicuddy, who asked a really good question earlier about what telescope we use. Monique Coleman, Nix Rin, and Ole Billy. PG, as opposed to Rated R. PG, Rico Taylor, me, that's me. Oh wow, look at me. Okay, Stan, Swarmer, Tara D. Tara D, of course, is the amazing Arizona artist that made the door for our SkyTour LiveStream West Observatory. If you haven't seen it, it's worth taking a look. I'm going to see if I can find a photo of that for you pretty quickly here.
Oh, cool.
Yeah.
Bye, Tara. Bye, Tara.
Oh.
And Mark, you mentioned earlier for all the newcomers, you mentioned where your shots can be seen. You want to do that
Sorry,
again?
You're right. I will. I'll just finish the list here. So after Tara, we have Tommy P. We have V. Hyatt. We have Volkish Fraulein. We have Willow Wisteria and Wise Eye, Wolfen the Gamer, and a Russian name I cannot read. I'm sorry. But I really appreciate you guys coming out to see us tonight. And that's just some of them. That's not all of them, because of the fact that I would have been reading over 600 and something names. But this is the ones that actually took part in the chat. Now, what I'll do real quick here, just to show you, I can show you the Arizona Observatory. I don't know why I didn't do this before. You probably want to see, or you should hopefully want to see, what we're doing out there. So let me grab that right now. You guys are really such you're really good connoisseurs, I'm sure. So here is the start of it. Let me just bring it up. That's the start of the observatory. We made a concrete pad. These are the workers that we hired to go out there and start building. There's so much stuff, and I won't take you through more of that. But what I will do, that's all right. What I will do is go back up a page here and show you how it all started. Okay, it all started with this view. Okay. I saw this view from the location before anything was ever there, and I decided, wow, there has to be something here. We have to put a dome here. We have to put a building here. It didn't turn out to be a dome. It turned out to be a building with a roll-off roof. So now what we do is we took pictures, and here's pouring the concrete into the pad, made the pad. That is Maddie. She's the dog that belongs to the owners of the property. And that's me going, wow, it's done. We have the pad. This here is Chuck, the owner of the property. This is Tara. Here, Tara in chat. Tara D. Okay. And this is like, wow, I can't believe it. And I was very pleased. And this is the type of landscape we're talking about. Okay. It's just a very beautiful location. And the skies are clean, crisp, and clear. And now, let's take you all the way now to, well, we'll start with this. This is our 3D printed moon that we make. It's actually 2¼ inches in diameter, and it has almost every crater on the moon. And I made that here. I own a visual effects company, and we make that here. And so we'll be offering those actually to people when we're ready. And to the person that correctly guesses how many bottle caps make up the door of the STLS West site. This is Tara's artwork.
1,326.
Buzz.
Negative.
Well, I wouldn't consider myself eligible anyway, but
No, but it's okay. But each of the bottle caps is visible here. If someone takes the time to count them, whoever comes within 25 wins this. Okay, I give them... This is a piece of art, by the way. This is hand-painted, okay, by me. As an astronomer, I know where everything goes and how it's supposed to look. I paint all the rays of the craters by hand. I want it to be a really, really, a good copy of the moon. And so the bottle caps were never actually colored in any way. It's just the natural color of the bottle caps. So
that's a lot of beer.
Well, yeah, she did. I was very careful to find out from her that she didn't drink all this beer to get this. She just collected for many, many years, actually a couple decades, I think. But if she's still here, she can tell you. Okay, so, but it is.
And tell them about the. Did I miss it? I was reading the chat. Did you tell them about the opening place on the door, the handle of the door?
Yeah, look at the screen.
Oh, yeah. All right. Well, then one picture
it's the bottle cap opener. Is the handle to open the door. I think it's so clever. And see, this is what happens when you leave things in the hands of an artist. You never know what you're going to get. And I absolutely love it. Here's the door in place on the observatory. And there's the observatory. All right. This is the roof up here. It rolls off to the east, toward that side, and leaves this opening interior. It's a metal-clad building. And the interior is wood, but painted. Thank you to Marianne Robb and to Tara Deulis, who did this. Here they are. We used a regular industrial garage door rails to carry the roof on and off. And all we did was install a regular garage door opener inside to make it work. And that's all it took. To me, it seemed like a real easy thing. I couldn't understand why everybody was saying it was going to be so hard, But we did. Here's the interior. There's a garage door opener. And you might wonder what these little things are. Okay. You know what those are? Those are bars of soap.
Wait, what?
Irish Spring soap.
Seriously?
Yes. Do you know why?
No, I cannot. Something to do with when it rains, the soap washes off the dust. No.
No,
so it'll smell good?
The roof would be on in that case anyway. The Irish Spring soap, believe it or not, it keeps away desert mice and rats.
For heaven's sake.
Mm-hmm. All you gotta do is buy a lot of Irish Spring. They hate
don't
it.
like it.
They hate it. Yeah, they hate it.
Howie.
Gaia says...
That's fascinating.
Daryl, Gaia's got a message for you in the chat.
I see that. She wanted me to sing a Christmas carol.
Oh,
right?
okay.
I think
would
you
you
know,
t-
probably. Which one did she mentioned it? The Christmas. Yeah. Oh, a Christmas song, any Christmas song. Well,
Oh,
what
then
what do you think, Daryl?
you guys want to sing
Uh,
one?
I haven't had anything adult beverage to drink, so
Oh,
not
that's
not
so,
tonight.
so it turns on
Oh,
that. Okay, all right.
all
Jingle
right.
bells, Batman smells,
Robin
Robin
laid
laid
an
an egg.
egg.
That's as good as you're going
Batmobile
to get
lost its
tonight.
wheel. All on Christmas. Yes, I remember those.
Well, it's better than nothing, Daryl.
Yeah. Well, you guys, you know what? Thanks for coming out. I really enjoyed having you all here, and I'm talking to you as well, Daryl and Carol. I'm also talking to all the people watching. You guys have been great. We got a beautiful view tonight of this stunning conjunction of Jupiter and Saturn. That's the real picture. That's what we really saw, and I'm really proud to have had all of you with me to see it. So I'm really, really, really happy. Okay. Daryl, I want to thank you for being here. Carol, I want to
Sure.
thank you for being
Thanks.
here as well.
Anytime, Mark.
It's wonderful.
Thanks for having me.
Oh, it's wonderful having you here. You know.
Good night,
so-
everybody. Merry Christmas.
Yep. You guys have
Happy
a
New
good.
Year.
Yep. And we will be talking to you again. And the next time we stream with the telescope, it'll be from Arizona. I may do a cloudy night stream from here, using some of our special applications we use to actually take you on live journeys around the universe, from the farthest galaxies to the nearest planets. We can go there, all of those places in 3D, in real time. It's a lot of fun, and we might do that for a cloudy night stream coming up. Until then, guys, you have a good night, and just remember, when you go out, you keep looking up, because we do. All right? Have a good night. Thank you again, Carol. Thank you, Daryl.
Oh, you're so welcome. I just want to toss in Amanda's tagline to keep looking up. She said, I think I'm going to paraphrase it. I'm trying. Unless you're driving.
That's right. I say,
Yeah.
keep looking up, and then she goes, except while you're driving.
Except while you're driving. There we
Yes.
go. Yeah.
Because she
Okay.
knows that I've made the mistake of looking through the sunroof at night.
Yeah.
Yeah,
Yeah, when it's a moonroof.
you
Okay.
got it. Folks, thank you for joining us on the Jupiter-Saturn conjunction night on this winter solstice of 12/21/2020. We'll see you again in just a few days from a cloudy night stream, or in a couple of weeks when we go live in Arizona. Good night, all.